Alright, we're going to have a look at question 10 to 15 and try to write a trig function to modeling this sinusoidal waves. So question 10 we went through it, so I won't go through it again, but I'm going to give you alternative answer for question 10. So let's have a look at question 10 over here. So we understand for this case A is going to be equals to 3, and we'll come back to B, by the way, sorry. So C, good thought, and certainly we can use cosine because actually start from maximum going down to minimum, and so hence if we use a cosine, that's not shifting anywhere, and D is also equals to 0, it's not shifting anywhere, and for this case B is equals to 2 pi and divide by the period, for this case is pi over 2, and we understand that's equals to 4. So hence if we use cosine, y should be equals to 3 cosine 4x. That's it. So question 11. Now A is going to be equals to 5, and C, if we use sine, equals 0, and D is not going anywhere. And then B, we can see is going to be equals to 2 pi over period, which is pi. Because we have 4 pi and then 4 of them, so hence that's B equals to 2. So since we use sine, it's going to be 5 sine and 2x. Okay, question 12. So amplitude A is going up into 2, down to 2, negative 2, so hence A is equals to 2. And okay, now we can use sine for this case. It's going to shift, and so hence C is going to be equals to negative pi over 3 because shift to the right by pi over 3. And D is not going anywhere, and B for this case and is equals to 2 pi. How about the period? The period is going to be 2 pi over 3, right? So it's 2 pi over 3. Let's give you 3. So y equals to 2, we use sine x minus pi over 3, and d equals 0. Now for this case, yeah, that's fine. Okay, question 13. A is equals to 4, because we're going up to 4, going down to negative 4, and C, I think probably we've done it, but it's fine. We shift to the right by half, so it's negative half, and D is not going anywhere, up and down, and B for this case, the period is going to be 2, so hence it's pi. Now y equals to, we use sine, so 4 sine pi x minus half. Okay, 14. Now amplitude, we go up to 2 and go down to 0, so hence it's going to be 2 minus 0 and divide by 2, because from maximum go down to the minimum, you actually it's taken twice of the amplitude, so you divide by 2, and that's can give you 1. And now C, if we use sine, it's not going anywhere horizontally, and D, obviously you shift up. So based on this, we can see the middle line, question 14, it should be around there. So it's between 2 and 0, I'll give you 1, right? So hence we understand it shift up by 1. So we have y equals to sine, B. What is B going to be? B is 2 pi divided by the period. Can't really see well from here, but it's fine. Okay, so we have maximum, we have minimum is from 1/4 to 3/4, so hence it's going to be half between those two, right? So from the maximum to the minimum is going to be half. Now we understand from maximum to minimum is give you half of the period, so hence the period is going to be 1. So B equals 2 pi, and x, since C equals 0, that's fine, and the whole thing going to be plus 1. You shift up by 1. Alright, question 15. So a is equals to maximum, for this case is -2, and then the minimum is -6. So distance between maximum and minimum and give you 4, but you half it, you have amplitude, so it's 2. Right, so that's -2, and that's -6 over there. You understand the middle line over here is going to be -4. Alright, so C, if you use cosine, it's not going anywhere, so horizontally, so C equals to 0, and D is go down to -4. Now, what is B going to be? B equals 2 pi divided by period. So what is period? Let's have a look. So from 0, which is maximum, to the minimum, which is 2. So hence this part, is 2. So that's from the maximum to the minimum, so hence it's half the period. So the whole period will be 4. So 2 pi over 4, that's equals 2 pi over 2. So hence y equals to 2. So we use cosine, right? Cosine pi over 2 x, c equals 0, and the whole thing minus 4. Thank you.